Hi everyone, this is Aman Soni from the AI team of GeekyAnts. So in the earlier session, we have covered the RAG approach. We have covered the entire theory of how the RAG works, why do we need one, how do we even get there to build one, right? So in this particular session, we'll be having a discussion. We'll be having a practical implementation of the entire architecture. So, but to sum up the last session, let me give you a quick summary. Initially, we'll be having a question that we want to ask to the LLM, and we want it to give the answers on the basis of our private data, not on the publicly trained data, right? So initially, you have the questions. Then after that, it will be routed to your knowledge base, and that from that knowledge base, it will retrieve some sort of documents. Those are relevant to your questions, and the documents those are retrieved will be then passed to the LLM model, right? So there are two things that will be passed to your LLM model. First one is the question that you have asked earlier, and second one is the relevant documents that those are associated to that question, right? And on the basis of that, the publicly trained LLM will give you the answers on the basis of your private data, right? So this is how you utilize your private data into answering the questions from the LLM, right? So initially, what we'll do is we'll import the necessary packages, and we'll import the LangChain tick token, the LangChain OpenAI model, the LangChain hub, the ChromaDB, which is a vector store, right? Then after that, the LangChain. Perfect. Then after that, after executing this, we have the environment variables which we have to set, right? So these are just the dummy API keys. Those won't work on your PC. So let me just run this cell. Okay. Then after that, we have the open API key, right? Then after that, let's run this. And after that, let's have a quick overview of how to quick start the RAG, right? So initially, we'll import the bunch of libraries. Those are important. Let it be the ChromaDB, the OpenAPI embeddings, Chat API, right? Web base loader, right? And after that, let's start with loading a document, right? So let's load a document. Uh, Let me show you the document that we are loading here. So this is the entire document that we want to index that we want to load in our model, right? So this is the entire knowledge base, you can say, that can be attached to that, right? So the answers that you can get from the LLM will be on the basis of this particular web page, right? So we have used the loader, we have used the web-based loader, and the web path is mentioned over here, right? Then after that we have passed. Okay, so in this format we want the parsing to be done. In this format we want my data to be organized, right? So there are three classes. First one is the post content classes, second one is the post title, and third one is the post header class, right? So in these particular classes, the entire content of this particular web page will be classified, right? And after that, we run this thing that is loader.load that will load the entire page that we have seen right now, right? Then we have to split the page, of course, because it's a very long article we are seeing over here, and we can't just pass the entire article in the knowledge base. We have to first split that into the pieces so that it is easier for us to uh, retrieve that, and it is much cheaper for us to retrieve that. Because if you pass the entire knowledge base to your LLM model, the token limit is going to exceed, right? The token size is going to be huge. That will create a lot of costing for you. So for that purpose, we will first split that into chunks, right? So we will use this library, recursive character text splitter, right? And the chunk size over here is selected as 1000, right? So everyone knows this, what this chunk size is. But what about the chunk overlap, right? Why do we use the chunk overlap? Let's suppose if you are splitting a entire paragraph after a dot, right? So there might be a scenario where there is context that will be lost because there will be a lot of paragraphs, there will be a lot of lines, those are mentioned above, which is related to that particular statement, right? So we need the token size of 200 to overlap, right? So it will overlap the initial 200 rows, and it will overlap the 200 rows after the particular line, right? After the particular chunk size that has been splitted after a particular like token, right? Then after that, we'll split that. The document will be splitted into chunks. Then after that, we have to embed that. So this is our vector store. We are using the ChromaDB, right? So ChromaDB from documents. Sorry, yeah, the documents are the splits that we have done above, and the embeddings model is used, right, to store vectors in a database. We need to have the embeddings first. So for that, we'll be using the OpenAI embedding model, right? The embeddings is done, and the vector store is having the entire splits of our data, right? So now we need the retriever. So in the retriever, we are using the vector store as a retriever, and it is from the ChromaDB only. Retriever and a generation, right? So now we have to pass the prompt. First of all, we are importing the prompt like hub.pull. It is a RLM rag prompt, right? So we are importing a pre-build mode, pre-built prompt. So you can also create a prompt on your own, right? I am importing that from this site. Right. Then after that, the LLM chat open API, the model name is mentioned over here, which is GPT 3.5 Turbo, and the temperature is set to 0. What does that mean? If the temperature is set to be 0, that means the model is not creative at all. That means it will only give you the answers on the basis of the context that you have provided. And it varies from the range of like 0 to 1. If I select the temperature to be zero point 0.9, that means it will be very creative with your answers. And even if the answer is not present in your context window, even if the answer is not present in your knowledge base, it will somehow try to create it, right? It might get the hallucinations. So over here we'll only select the 0 just because we want the answers from that particular paragraph. Then after that, the post processing is done. So define format docs and the return join the doc dot page content for doc in docs, right? So it will run a for loop over there, and it will give you the results in a very pleasant way, right? Then after that, the chain is used, rag chain, and there is this context which is retriever, right? And after that, in that chain you have format documents and the runnable pass through, right? Then after that we have the prompt, and then after that we have the LLM, and we have the string output parser that will pass the documents that we have received, the pass the or outputs which we have received from the LLM in a string format, right? So this is the entire chain, and we'll run that chain, and we'll get the answers to that particular questions, right? So let's see what is decomposition. Let's do one thing. Let's first see that in that particular block, sorry, control find, and here's a decomposition, right? Task decomposition is given over here, and we have the entire paragraph for it, right? So let's run it and let's see what our model gives us. Control and enter is the shortcut for running any cell, right? So here we got our answer from that particular website, which is the task decomposition is a technique that break down the complex task into the smaller and the simpler steps to make them more manageable. It involves a lot of things, right? So this is the entire flow of how the rag works. Uh, First you get the questions, then you attach your knowledge base, which in this case was this website, right? And after that, that base is attached, and after the question that you have passed, that will be the relevant document from your knowledge base will be retrieved. So there were a lot of documents just because we have splitted that into 1,000 chunks, right? So uh, every chunk has a different document. Every chunk is a different like set of words, set of sentences, right? So the relevant documents were fetched from the retriever. Then after that, those documents were passed to the LLM, and the LLM was giving you the answers on the basis of the documents that we have already retrieved, right? So this was the entire flow of the RAG architecture.